Hi, welcome to my YouTube channel on the build of the MBR Osprey road car. In this episode, we're finishing off the handbrake, hey, just like my haircut, just been done. And on from that, I've got a little bit of a clip from the COVID times, so that's in there. And then finishing off with that, the air activation system of the gearbox. So yeah, let's crack into the workshop. A few pictures of the race cars because I thought you might like to see them. And yeah, then straight into the video. Enjoy. Okay, so back on the caliper. One thing I forgot to mention last time was my welded on bit to hold this spring. So as you can see, that's done. So now both caliper sides are done. The other one over there is on, as you can see. What I've got to do is I've cut the cable slightly longer than needed to, and I've got enough for both sides. What I've got to do now is start working my way from back here towards the front of the car, so none of this moves. Because if the cable moves, I'll get the lengths all wrong. So what I've got to do now is fix this up here, and if you can see just here, I've made a mark, and what I'm going to do there is I'm going to drill and tap into there so I can put a nice P-clip on there so I'll get a nice run. I've been looking at the various ways I can run this cable, but I can run it back this way more, but as you can see down there, it puts a nasty bend, not a nasty bend, but a bend, and with cables, the straighter they are, the better they work. So the only downside with coming here is I'm getting close to the exhaust, but worst case scenario, I can put a bit of heat protection around there, just like I have up with these cables here. So yep, okay, on to the next bit. As you can see, I'm tapping. Another little tool I've done is, this is just a standard tap, but what I've done is I've pressed a socket on the end. So when you're in situations like this, and it'd be very hard to get a tap wrench onto it, you can just use a normal quarter drive, which in this instance is very, very useful. Okay, so yeah, I'm back on the mill. I've made one of these cable clamps. I just thought it's quite a simple turning job, 2 diameters, thread, and then just a through hole at the end. But what you've got to do, what I'm doing now, is trying to drill a hole on a round piece of bar, and that's not a very easy thing to do. So what you can see there, if I zoom in, is I've just put a flat across the top of it. Then that enables me to go down through with the drills to get a nice accurate hole down through them all the way through. So once I've done that, I've got to tap it, then black it, and they're all done. Great, I've finished making all the parts now. As you can see, I'm done a little mock-up. My next thing is to mark the floor out so I can get these into the correct position, and then drill them down and bolt them up through the floor. Once I've then done that, I've got to do get the length of the outer cable absolutely spot on, and then I can run the inner and get the handbrake to work. So I've got the brackets nicely fitted on. Next little problem that I've come across, nothing major but just slightly annoying, is that this cable end here slides on there quite nicely, but this doesn't fit into that, which it should do. That's all part of the kit, and that's 6.5 mil. Sorry, that's 6.5 mil, and that's 7 mil. So I've just got to put this out and take a little bit out of this. Just annoying, nothing else. Okay, so I'm back on the lathe, just quickly showing you how I've got to modify the adjusters. Even the adjusters, when I've looked inside, they've just been drilled. So what you really need is, you don't need a tapered end, you need a flat end, because the part going in here is flat. So what I've had to do is, I had looked if I'd got a 7 mil reamer, because that's got to be 7 mil, and I hadn't. So I've had to get a drill and flatten the end off of it so that I could get a nice flat end for the boss to go up to. So just show you what I've got to do here. I'll try and talk loud because the machine's quite loud, and very little I've got to do. Just got to go in like so until I feel it stop, which is there. Flat bottom it. Back in the cockpit again after being on the lathe. Another idea I've come up with is I was worried about these nuts shaking loose because there was nothing holding them, just a standard plain nut. So I fitted one of these. They're called snore washers. They've got lots of little serrations in them. I don't know if we'll get it in focus. You can just about see them there. And they're a lot better and a nicer option than the old version, which was a standard spring washer, as you can see here. So yeah, that's just another little thing that I'm doing. And then on top of that, I've got the, if you look over here, the end now fits really nicely into that adjuster. So now I can crack on with getting the cable to the right length. Okay, well, here's the handbrake in motion. It's really tight now. You can see all this has worked really well here. My adjusters, these work well. I've had to adjust them a little bit to get them even both from side to side. And I've got this adjuster here as well for overall adjustment. So that's, yeah, huge amount of adjustment there. And by using it, it's worked really well. We come to the back now. And as you can see, again, I've had the adjusters here, a little fiddle with them to equal the sides out, and that's really tight. And come over, and this one here, equally as tight. So yeah, one handbrake system finished. Right, we're on to exhaust system. Now, this is take 2. I haven't done many takes. This is only my second one that I've mucked up. I mucked up the one earlier, so it's Monday evening. I've had a glass of wine, so hopefully this will improve my description of the exhaust system. Right, starting off here, we have the primaries, also known as headers if you come from America, Albert. These were left over from the original project, so I would love to have a set of stainless exhausts on there, but unfortunately they're quite expensive, so I've remained with the original primary. So I'll explain what happens. So the primary pipes here come down into this collector pot here. And then round. Now this little thing here, if you don't know, it's called a lambda sensor, and what that does, it measures various gases that come out of the engine, and it transmits it to the ECU, and then obviously the ECU can tell how rich, lean or whatever the engine's running, and it can alter it accordingly. That's what happens when you have a clever ECU. Right, comes round. Now, system 1 on the exhaust, I've got 3 systems. So the first system, the exhaust is going to come out here and straight out the side. So I don't know if you know, but a Rover actually makes quite a nice noise, and obviously with no silencer it will make some belting noise. So that's exhaust system number 1, which might be a tad illegal. And we come round through the silencer and out the back there. That's going to be exhaust system number 2, which still be fairly noisy, but yeah, not too bad. And then we're going to have exhaust system number 3, which obviously, as you can see, is non-existent at the moment, and that's going to be obviously have a catalytic converter in it and obviously another silencer, so that will be totally and utterly road legal. Right, a couple other bits about the exhaust system. I might have explained earlier that one thing I can't stand on a car is rust of any description. So what I've done, if you look through the whole car, is made sure that all the bolts are either plated, anodized, or we use stainless steel. So if you look here, I've had to make 16 of these engine studs. They're all made out of stainless steel, and really weird size, 3/8 UNC one end and 3/8 UNF the other side. So I've had to make all those studs individually and put them on. The exhaust system, it's not actually properly finished, not properly fitted yet, but I have done some bits, like obviously here you can see the spring. It gives the exhaust system a little bit of flex, yeah, it runs very, very close to the floor. And if you can see, one of the biggest jobs I had was actually getting it just off the floor and just missing the suspension. As you can see, it just does. It's all a bit tight, but just about managed to pack that in there. Okay, so that's the exhaust system. Right, next up, what have we been doing on the car? Well, every week obviously there is progression on the car, and Adam's obviously doing bits and pieces up at Hotcliffe in his design studio, as we should put it, and one of the things he's working on is the mirrors for the car. Now he needs some parts making, and he sent through this drawing of a stud. Well, obviously I've made them, as you can see here. There's the 2 studs that he wanted to, one for each side obviously. Now if you look on the drawing, he's actually asked them to be made of stainless steel, which normally isn't a problem. I can get hold of stainless steel, but obviously in the times we've got at the moment, trying to get hold of it's time consuming, takes some time. So I hunted around to see if I had any stainless. Unfortunately the size that he wanted I didn't, but what I did have was one of those. So what I've managed to do is make 2 studs out of 2 bolts. So quite happy with the way it's turned out, and jobs are good. Next up, he wanted these. Basically these are to put the mirror on. And again, if you look at it, he's asked for stainless steel material, wherever it is, material. No, not available. He hasn't. Oh, there we are. Stainless plate. There we go. You've on it somewhere. Unfortunately, 75mm OD stainless. I just didn't have anything that was that thick. So after a conversation with him, we came up with the idea of actually using aluminium. So there we go. Here's one I've made out of aluminium. Now, as you may or may not know, aluminium and putting threads into it's not perfect. So luckily, we have one of these things. If you can see it here. Yeah, with two little ears on. That's called a key insert. So what I did is it's an M5 thread that should be in there, but if you tap it out M8, put one of these things in, and then knock those two little pins in, which you can probably just about see there, you get a very strong thread. So that's that was a compromise design. So there we go. 2 plates done. Right, now I wasn't going to mention porn, but I have got some porn for you boys. It is a Tuesday night, but unfortunately this is engineering porn. Now, a little bit different. One of the first tasks that Adam had in designing the back end is obviously the transmission that's going to be on the car from the other car to this car is different. The front face of it is a totally different design. So we needed what they call an adapter plate to adapt the engine to the gearbox. So fair play to Adam, he drew it, and he's come up with a glorious designed adapter plate, as you can see here. This is his version number 2. Version number 1 was even sexier, and it had all sorts of Formula 1 gussets, cutouts, God knows what in it, which was brilliant, but unfortunately the price went up, and so I had to say to Adam, we can't have it that nice, we'd have to make it a little bit cheaper. So he did, and yeah, I luckily had a customer come in, wanted a gearbox job doing, and he wanted a gearbox job, and he had an engineering company, so he machined the adapter plate for me. Obviously I couldn't do it here, and yeah, I mean just the plate of aluminium itself was 150 quid before we even started, sorry, 175 quid before we even started machining it, then had to be machined. So it is the single most expensive item on the car, I mean, on an individual thing. So yeah, very, very pleased with it. I think it should go in the Tate Modern as a piece of art. If you look at it, he's also not only had to mount the engine to the gearbox, there's here, we've had to mount the suspension off the adapter plate, top wishbones mounted, and also the bottom, and loads of other little bits. Obviously had to mix the clutch, and obviously if you can see, I might be able to see in just in, whoops, I'll get it focused in a minute, somewhere in there, obviously things like the starter motor coming out, so quite a big undertaking to make the adapter plate. So very pleased with Adam on that one, and it's yes, a bit of engineering porn for you. Drive shafts, the part on the car which takes the drive from the transmission gearbox to the upright, and then obviously through to the wheels. Now on this car, I have one particular problem, as if you can see, if you look at the joint on this end and you look on the joint on that end, they're totally different. When we first designed the car back in the late 90s, this joint was the common joint, called a low-row joint, CV joint, constant velocity joint, various names for it, but that's what it is. And we have one of them on both ends. Now, because I got a later spec gearbox, it came with what they call a tri-lobe joint, which is a totally different type of joint. So before I go into how we made the shafts, etc., I'll show you a bit about the joints. Here we are. Right, over here, this is what we call CV joint, low-row joint. Now it's got 6 balls in it. The inner one driving through the balls, driving the outer one, and the cage keeps all the balls in the right position. As you can see, it plunges in and out quite nicely. And this is a self-centering joint. That's quite a plus bit to this joint. Now the later one, the tri-lobe joint, is here. And what you've got, you can now see why it's called tri-lobe. You have this little plunger down inside with a spring. Then the tri-lobe goes in, and then the drive shaft goes in like that, and then this cup goes in, whoops, held in with a circlip, and then the boot over the top of that. Now, the other issue that I came across when doing this is if you look at the centre splines, you look at that spline, and you look at that spline, you can see one's coarser than the other one, and one's a bigger diameter. So that threw up the next set of problems. I had to, when having the shafts made, I had to make sure we could get the cutters for both ends of the shafts. Right, leaping back across to the car again. why do we need constant velocity or tri-lobes on the car? Well, as the car suspension moves up and down, it changes the distance between the upright and the gearbox. It's a bit too stiffly sprung, so I can't do that. But so what you need is you need some movement in the shaft. Now, when you're building the car, you need to have what they call plunge. So obviously it's in full bump or full droop. You don't want at any point the shafts to be locked out. So if you listen carefully or look carefully, you can see the shafts going in and out. If I say nothing, you'll also hear a little bit of noise, hopefully. Right, and that's as I'm compressing the drive shaft. Obviously I'm compressing the air in there at the same time, so the air wants to come out. So rather than it blowing through grease out of one of the holes, what you do here, you see that it's a little straw we put in. Now that lets enough air in and out just to let the joint breathe, and it normally stops most of the grease from coming out. And again, I've got the same on. Oops, lost it. Yep, there we go on that one as well. That's just a little racing engineer's trick. Right, next up was how did I get that length sorted? Well, I was lucky enough here to have two shafts, both old shafts. So what I did, the bit larger shaft here, I bored it out and then put a joint on each end, made sure the smaller shaft slid up the middle, put the car on the ground, made sure that the car was at ride height, and then I basically put the shafts, marked where the shaft was, made sure I had plunge, and then marked it, took it out, welded it, and then gave the suspension a good testing to make sure it was all right, and it was, and then drew this shaft up and had it copied. And that's how I ended up getting the shafts. The shafts made. I couldn't make them here myself. They have to be made out of special material and they have to be heat treated and straightened. So I got that done by a company in Birmingham. One other little trait for you might find quite amusing. These joints here, they're actually an MBR mod. When we were running the F3 team, they ran a very similar gearbox to this, and the joints that came on the car were direct from Hewland, and just to say they weren't very good was an understatement. They always kept falling off and just not nice. So I came up, I bought some cheapy joints on eBay, decided to modify them to fit this, which they did suitably, and yeah, we used them for 2-3 seasons in Formula 3 without any problems. And then when Formula E came along, their spec was a standard Hewland boot, and they were having all the same problems that we were having. And I was dealing with one of the teams quite a lot, Andretti Racing, and I said, oh, we can't stop these boots from falling off, what can we do? I said, oh, try my joints. They tried them, loved them, they got Formula E to approve them, and we are, I think we still are actually, official Formula E suppliers for that one component. So yeah, okay, well I think that concludes the drive shafts. Right, so now we're moving on to the air actuator, which I think I spoke about in a previous video. It's connected here, and I've got to mount it off of this rod end. Now what I was going to do is, I've got a bracket here which was bringing into the picture. I was going to mount something like this here and put that on, which it's not bad, but it's what they call in shear, so it's always trying to sort of break it in that direction. It does work because there's not a huge amount of load going through it, but I think I could do something nicer. And I had a scout through my brackets as I did on the handbrake, and I have found this bracket, and as you can see, I can bolt it against. I go in, bolt it against there with just 2 6mm bolts. I think that's going to be a lot easier, a lot simpler. So I'm going to go this way. All I've got to do here is drill and tap into there, and I've got a couple of top hats to make there. The only tricky bit on the whole thing is getting it in the right plane here and the right plane fore and aft, basically. No, fore and aft and up and down. So I'll do that. I'll probably put a little time-lapse video on of me mucking around with it to get it all in the right place. But yeah, this is going to be a lot simpler job than I initially thought it was, which is quite nice for a change. I've just put my famous blue tack on the top and bottom just to hold it in position. What I'm going to do now is just go through with a marker, mark that hold position. Then I'm going to drill and tap, or drill it 5mm for a 6mm tap. I just do one side, and then I'll knit that one side up, and then I'll make sure this bracket here is level across the top, so that it isn't wonky at all. And it's probably the best and easiest way of getting in there. I mean, I could take everything to bits to do it, but I'm pretty sure I can do it in situ. I've tapped the thread, and So with an M6 thread, to get the depth right, you do it by what they call diameters. So, or the depth of the thread right, you do it by diameter. So if you've got a 6mm bolt, a 2D would be 12mm, 1.5D would be 9, and 1D would obviously be, I'll say that word again, sorry, it would be 6mm. Most situations 1.5D is good enough, so that's what I'm going to go for. So that's just to tell you how the depth I've done. Now I've got to get it fairly level, and as you can see I've got a level on there, and that's pretty good. So what I'm going to do now is on the other side through here is pop a hole so I can finish and get both sides bolted up. Yeah, this thread's a little bit tricky to get into. On the one nearest me thread, I could use a normal tap wrench, but you can see here what I've done is I've got a socket and put it on the end of a tap, so I can use a normal ratchet to get in there. It's the only way I can get there because I just haven't got enough room to get a normal tap wrench on. It's a bit slow, but it's the only way I can do it. Well, that's nice. The plates now, or the bracket should I say, is now on. I've got to make the top hats to go in here, which should be a fairly simple job. Make them the same, so that's then nice and level. And the only thing else I've got to do is then work out the throw, because this is probably about out too far, this rod end. And if you look here, you can just see these two marks. This is when the piston's fully extended. The line there is when it's in the middle, and the top line is when it's out the other way. So I've got to try and move it at least to that first line, which is I've got a bit of plate here. And as you can see, that's slightly thicker than where that first line is, which is fine because I've got some adjustment on there. So I'll just cut this plate to go behind the bracket there. So yeah, okay, I'll crack on with that now. Right, so I've made the inserts in here to stop the movement of the rod end going up and down. You see that on the little lathe shot I've just taken. I've made the spacer to go into the back of the block, and that's worked really well, because if you look now, I can show you what I mean about the throw. If I move this piston that way, it just comes to the edge of the rose joint there. And if I go back the other way, like so, that's it there. So I've got the throw about right now. What I need to do now is actually test it to make sure that it does actually work. And what I've done here is this is an M6 thread, where the other end I've used an Imperial. I've used a nice NAS bolt, as I previously explained, so that's worked nicely. But here it's got to be an M6. So what I've done is I've cut down an M6 bolt to have a load of plain shank on it. The only downside with this is it's just a little bit of movement up and down on this rod end here. So what I've got is a very small washer, which I can just fits in there. It's a bit of a tight fit, which I've got a screwdriver to get it in. Bit of fiddling. That's in there. Okay, so that's got that in. Okay, so that's nipped up. As you can see now, there's no up and down movement on that rod end, which is very nice. And now if I put that on here and that on there, I can show you the gearbox going up and down. That's up the box, that's down the box. So I've got enough throw in this canister. Okay, a couple other bits to finish off, but I can't do now. I'll be doing that maybe after the first time the car's got running, because I sent a whole load of blue anodizing away, and as you can see, I've added some extra bits that need blue anodizing. There's the spacer here, there's the bits for the brake calipers, and a few other odds and sods around the car. So it's a lot cheaper and easier to batch it all together. So at some point in the future, I'll batch it all together and get all that blue anodized, but that's not until after I've got the car running. So in the next video, what I'm going to do is these two outlets here need to go to what we call the valve block, and the valve block is going to be mounted up in this area. So that's what I'm going to be concentrating on next. And yeah, so pleased with the way that's gone, and thank you for watching. Please, the old normal like and subscribe, and the next video will be out shortly.